Great. Yeah. So as you mentioned, Shuar, today's discussion about real-time monitoring and predictive maintenance of overhead catenary system with train-borne data capturing technology or train-borne system. We are Ponto Health in Berlin, Berlin-based company working on real-time monitoring and simulation of pantograph and catenary. We have a deep focus on pantograph and catenary, in particular when it comes to the maintenance. So we do believe that there is a gap between the data collection and also the people in the field who are executing the maintenance action. I mean, even though you are capturing gigabytes of data with banana trains or measurement train or whatever you call it in different markets, still people in the field are struggling with digesting this data, and the situation is getting even worse because nowadays when we are talking about train-borne measurement system or real-time monitoring, 24/7 data collection, the volume of data is getting more and more, and still there is a facilitator which can digest data and bring information to the people in the field is not available. So we want to fill this gap with some AI techniques, which I will be presenting in future, and also some logics, which I will be presenting in next slides. Before going to the deep detail of the solution, I would like to give you some sort of concepts about the correlation between reliability you have in rail industry and also using big data and statistics. So the more reliability you want to achieve, for sure, you need to capture more data. That's a basic rule. But we have, not we have, according to the literatures, the whole maturity matrix of the maintenance action can be classified in 4 different levels. The first level is visual inspection. The measurements, the some kind of maintenance measures which have been done so far, and it needs minimum level of data and delivers for sure minimum reliability. The next level is instrument inspection, which you measure some parameters with some instruments. For example, running measurement train once per 6 months or once per 2 years, or measuring the thickness of contact wire when it comes to overhead catenary system once per 5 years, is some kind of policies in the instrument measurement or instrument inspection in level 2. But if you leave the sensor forever on any train, which in UK you call it train-borne monitoring system, that would be level 3, which is real-time condition monitoring. And you capture data 24/7. And with this, you will be more reliable, but the data which you are gathering would be much more than the level 2, which is instrument inspection. And level 4, which is predictive maintenance 4.0, or the fourth generation of the maintenance maturity, or let's call it, or even someone call it prescriptive maintenance, needs even more data and deliver higher reliability. So I want to have a bit deeper focus on this 3 concept of measurement, monitoring, and predictive maintenance, or prediction analysis. In measurement, what is important is that you are using a well-calibrated, high precision system or equipment to do the measurement. And another important factor is that you compare the measurement results with some predefined thresholds. And if the measurements are more than that thresholds, you report it as an abnormality in the line or whatever. But when it comes to the monitoring, the precision can be not as high as in measurement. Also, the whole data treatment is not a simple comparison. You would be mostly looking for trend analysis. And in addition to that, the equipment should be installed on a commercial train. Then that would be some kind of monitoring and not measurement. And in level 4, there is important fact that you need to perform deep data analysis on the collected data to claim that I am at the level 4. And in level 4, you will be mostly looking for some sort of correlation between cause and effects, not just comparing with thresholds or finding the trends. And there's one important fact that the data difference between level 4 and level 3 are mostly coming from digital twins, because once you have equipped the train with some sensors in level 3, Probably you would be asking, okay, in level 4, there's no more data I can capture. Yes, there is no more real data you can capture, but you can rely on the synthetic data, not sensoric data, to train your AI engines, to train your algorithms, and to answer what if scenarios. When I'm talking about what if scenarios, I mean with the digital twin or with the simulations, you can simply run different scenarios of, for example, pantograph and catenary interaction. Try to see what if the tension of contact wire is loosened, what if one dropper is broken, what if, and thousands of what if, and then see this effects on the results, and then by training your AI system, you can figure out, okay, this kind of output or result in the signal is the consequence of missing this component or having this type of failure. That's the gap between data in level 4 and level 3. Okay, so with this introduction, I would like to introduce our solution, which contains 3 main steps. The first step is data gathering. So data gathering can be also done by 3 main pipeline or streamline of the data. The first point to gather data is like the available data by customer side. Just as an example, here is the measurement data of a measurement train in Deutsche Bahn. As you can see, when it comes to pantograph and catenaries, they measure contact force in 250 kilometers per hour to be sure that there is no stiff point, and besides that, there is no point which the measurement with the force is more than 300 Newton. Also, they measure other parameters like the lateral distance between ongoing and incoming wire. And many other parameters to do. But they run it once per 6 months. They compare the results with some thresholds and define some problematic points, sometimes even in an Excel sheet or whatever. And then they dump the rest of data to the cold storage, which probably never be used later on. We had a project with Deutsche Bahn tried to unlock or do more analytics on the available data of 100 kilometers of the line in last 10 years. So this kind of important data is feeding our AI engine to be able to even deliver better and higher precision results. The next data input would be our device if it is necessary. So as we mentioned, as a title of this presentation, it's about train-borne monitoring system. It means you equip a normal passenger train with some kind of sensors, and we have different options here. We have different options here. For example, you can start with some kind of vibration-based monitoring, or you can go ahead with more advanced options, which is profiling-based monitoring, which can scan the contact wire and deliver important informations like zigzag height and even thickness of the contact wire. So it's a modular platform. You can equip it with more sensors, for example, thermography camera, arc detector, missing component detector, and whatever you like can be added to this platform. Again, the data itself is not really critical things to define the solution. The method which we treat the data and the method which we deliver the information to the client is the most critical point of this solution. So that was the second pipeline. And the third pipeline of data collection, as I said, is our digital twin. So I want to also highlight that there is a difference between digital twin and digital models. If you onboard a company to make a reality capturing or do point cloud scanning, that the result of such project would be the digital model. But if you have a software or you have a mathematical model which can simulate different scenarios on your 3D model, that would be a digital twin, which I normally call it having a soul into your body. You know what I mean? For example, if you make a 3D model of your house, that would be digital model. But if you are able to see the effect of earthquake, for example, or if you are able to see the flow of the heat to design the HVAC or whatever. In that case, you will have a digital twin of your house. So in Pantros, we do have the digital twin because we can generate the mathematical model of pantograph and catenary interaction. And this mathematical model has two main applications. The first one is for designing the line to be compatible with TSI norms, to be compatible with EN norms. And the second application is feeding our monitoring system with some kind of pattern, thresholds, and border between normal response and abnormal response of every and each design of catenary in different countries. So that's the application of digital twin. But at the end of the day, when you feed your analysis, your data pool with this three data resource, you can deploy your machine learning algorithm to end up with three main questions. Where is the problem? What to do to solve the problem? And when is the best time to do the maintenance or react to the problem? So where is the problem is normally kind of easiest point to find out, but what to do to solve the problem, which is somehow prescriptive maintenance. And when is the best time to do the maintenance is reflecting predictive maintenance. With these two, you can reach the PDM 4.0, which I was mentioned, that is the highest or the maturest policy in the maintenance strategy. So when you reach that level, at the end, the data should be delivered to the end user, which is as important as the process you have done to reach that level. You know what I mean? So if the user can communicate with the platform and can receive data information, not raw data, and deploy it in day-to-day work, you are the winner. And we are deeply working on this things at the moment. The panel which the user can use for finding problematic point of the line is look like this one. I can even show you the live demo of the panel. So we highlight the potential problematic point across the line, as you can see, and we have some indicators called health index, and the user can simply sort out the different points based on the health index and jump to the points which has higher priority. That, based on hours of the discussion, internal discussion, customer interview, and brainstorming, we ended up with this way of visualization. But it's really important to know that we have three main steps in our data processing. First is problem identification. So we give identity to each and every potential problematic point of the line. And we have a dedicated AI algorithm to find out the pattern of the abnormal part of the signal. You know what I mean? When it's, if it is section insulator, crossing, or whatever. So we identify the problematic point, and we put all information related to that geolocation in the same place. So we highlight each point with some kind of exact geolocation, and next time this train or any other train is passing through that point, we grab a window of signals and data and send it to our software for further analysis. And at the end, in the same software, we have maintenance and task management and feedback. It means the user can intervene the whole software and say that, okay, this point, also you told me it's problematic and important, but when I checked it, there's no problem. And this is a closed feedback. This kind of information comes to our panel and helps our software to find problems better and more reliable. So that was about the whole concept of our software and the way which we treat the data. I have some complementary slides which highlight our use case and which explain how did we went further with our projects in different cities. So as an example, we deployed the set of hardware which was profiling-based monitoring to measure the height and zigzag of the contact wire. Then we installed vibration-based monitoring to detect hard spots or abnormalities of the contact wire, and also the camera for visualizing and sometimes even finding the position of the contact point in some, and also arc detection. Besides that, the methodology which we used was anomaly detection, which I told you, which is the first step of our software, and problem prioritization, which I'll explain in detail how it works. And at the end, the problem which we could detect was a misadjusted section insulator in both cases, in two cases actually, and low wire thickness only with vibration sensors, which was quite impressive. So here is the overall shape of the installation. As you can see, we have installed different sensors or components and different part of the rolling stock. As you can see, there's a camera in a good view to the pantograph and catenary. There's accelerometers on a pantograph side and a contact wire scanner again on some point which normally have a good view to the contact wire, I mean down to top view. So here is the way which these sensors or this hardware are capturing data. For the camera, again, it's mostly for the visualization. Accelerometers shows the hard point and abnormalities, and a lot of preventive measures can be extracted by digesting the data of accelerometers. Because vibration-based monitoring are one of the advanced methods of monitoring and can detect the issues in much earlier stage. And contact wire scanner plus zigzag and height measurement of the contact wire, this setup has been defined to be a complement with the regulations and standards. For the thickness measurement, that's another example, which you can see based on the brightness of the worn out area. The system can detect the thickness, also zigzag, which is quite easy, and height of contact wire. We do some kind of image processing to find the distance between contact wire and camera installed on the roof of the train. I told you a lot about the methodology which we have, the method of animal detection and health index calculation. Assumes that train is passing through that point. Once it passes through this point, which our AI algorithm is showing there is a potential of abnormality, it sends a package of information here, and not only sending package of information, but also highlighting the geolocation of that point. And from now on, whenever the train is passing through that point, we will be receiving a new window of information. So again, we highlight the geolocation, and based on the GPS of the train, next time train is passing through that point, we will grab a new window of information, and we calculate the health index with our fuzzy algorithms. What is health index? Look, we don't want to bombard our clients or our customers with thousands of different information. Suppose that you have thermographic camera, arc detector, you have zigzag, you have thickness. So at the end of the day, the client wants to know how important it is to fix this point as soon as possible. Or if I have time to fix only one point, which point should I select in the panel? And for this, we combine all these inputs and extract some sort of health index and sort out all points with the health index. So again, that we can sort out these points with this health index, and what user will be seeing is a simple platform like this, which each time train is passing through some points, the priority of different points will be changing, as you can see here. So by passing the time, new points which are more important coming up, and ask the users to have some kind of reaction to that sort of problems. With these methods, we could identify some problematic point in a real line. As you can see, this section insulators, as you can see, this section insulator is having some sort of loosened turnbuckle. And this loosened turnbuckle is somehow misadjusting the whole ski rods of the section insulators. And each time when the pantograph is passing through that section insulator, it hits the pantograph and make a micro damage to the carbon strip of the pantograph. To avoid that, it wasn't a heavy job to do. We just asked the colleagues to fix the bolts a bit, somehow tighten the turn bolts. And then we understood that even this simple maintenance measure can make quite a significant improvement in the whole data collection of train-borne monitoring system. And this point automatically dropped down after the repairment. Another example was this section insulator. As you can see, the entrance point of the section insulator is much smoother rather than the exit point. And here is the video. As you can see, there is a spark here because of really misadjust. And you can see there are a couple of bolts here, and they can simply adjust this bolt. Of course, in next action, I mean, when the software is even more mature, I mean, our maintenance software, we can tell the maintenance team, go there and tighten the bolts in the right side for like 5 round or 5 millimeters, you know what I mean? So that's how they call it prescriptive maintenance, when you send the people to the field with some detailed prescriptions, not just with some hints that there is a problematic point in this area. And at the end of the day, we understood that even with vibration sensors, we can find out some points which is more probable to have low thickness in the contact wire. How? Because we measure the vibration of the signals in 3 directions, and when we see an excessive lateral vibration on the pantograph in some points, we can expect higher veer rate even in that points. And we could find this one of this potential problematic point sharp on one curve, and the thickness of that thickness of contact wire in that point was almost close to the dangerous area. So with this input, we made some kind of cause and effect chain or root cause analysis of the pantograph and catenary, how from minor faults can go to the system failure. And we ended up with this chain of cause and effect, or chain of defects. The first step would be a hard point or irregularity in line, which I showed, for example, this section insulator, which is misadjusted section insulator and can make a minor damage to every and each passing pantograph. Second step is damage to the, or roughness to the carbon strip of the pantograph, which is a notch or whatever you call it, a crack. And third step is increase in wear rate in the contact wire, because you don't have a smooth carbon strip anymore. So you probably will be expecting lower thickness in the contact wire at curve. Why curve? Because in curve you have normally excessive lateral vibration. So and when the thickness is really low, the step 4 is like a contact wire failure. So to make it clear, I would say in the whole root cause analysis of our case, we could find 3 main cycles. In the first cycle, or in the first chain, the cause is hard point or irregularity in line, and the effect is a damaged pantograph or damaged in a carbon strip of pantograph. So let me come from the other side. It's better or easier. If you have contact wire failure, what is the reason? For sure, the reason is low thickness in the contact wire or high wear rate in the contact wire. That's the cause of this effect. But what is causing a high wear rate in the contact wire? That's the effect of another cause, which is called, which can we say is damaged pantograph or high roughness in the carbon strip, okay? And what is making damage in the carbon strip of pantograph is for sure a hard point or irregularity in line. So you have 3 loops of cause and effect, and we in Pantos can deliver some system which can detect the first step of the first loop, hard point or shock detectors, and the first step of the third loop, which measuring the thickness of the contact wire. So that was the root cause analysis of one of our example. I guess I have time to go to another example, which in the city of Bergamo, the line was brand new. And with a new line, I mean, the clients were expecting no danger or risky point in terms of contact wire thickness, but our system suggested 3 point to be monitored or to be checked based on abnormal shock to the pantograph. And you can see that's one of the points. If I even the sound of passing pantograph is a bit weird, but when we had a deeper look to the contact wire, we could figure out that the thickness of that a specific point of a brand new line is getting critical. So in 99% of the line, the whole lifetime was more than 30 years, but in some points, few points of the line, the lifetime is less than 10 years. And the root cause analysis of this example is a minor hard point or irregularity in the line, and it could be misadjusted mast, which can directly affect the thickness of contact wire in the same point. For sure, it can make damage to the pantograph itself, but one of the most important consequences would be low thickness contact wire, and at the end of the day, even end up with the failure if they don't figure it out and react immediately. So again, our system can detect this causes in 2 stage, and we can implement it with, on a normal rolling stack. With this slide, I can finish my presentation. So I think if you have any question, you can ask my colleague Mahya, because I need to jump to other meeting right now. Is it okay, Stuart, if I leave the call?
Yep, that's great. Is Mahya on?
Yes, I think so.
Thanks,
okay. Andy.
Well, Farzad, thank you very much for the presentation.
Thank you.
That's really interesting.
Thank you, and bye. Hope to meet you again. Bye, guys.
Have everything it should work. So you.
So Mahya, I can see you in there. Are you okay for taking questions?
Yes, definitely.
Right. I'll try and summarize some of the stuff I've seen. Nicholas Snell asked a few questions, but unfortunately I see he's had to disappear. But there's been quite a few that are around trial sites for the system, and where the system has been approved, and in fact, has it been trialed in the UK? So if I wrap those sort of 3 questions up together.
Okay, regarding our system application in UK, you're asking?
Yes, that's one of the, yeah.
Okay.
We're outside the UK, but also has it been trialed in the UK?
So far, we have not done any installation in the UK system, but overall, we have been in touch with some kind of standards company which are deeply working on the new technologies and new products which needs to be integrated into the network rail system or the other systems. And we were very open for them to do the due diligence in terms of the software side and hardware side both. So make sure that we are totally compatible with the systems. And also we have some kind of meetings with network rail people in the electrification department. They asked us about how do we do the installation, how we are running our software, and what added value we can do to that. And more or less, so far, we have not seen any, I can say, a strong barrier for implementing our system in the UK. But maybe if we go to a pilot project or exactly something that we need to do the implementation, maybe we need to, for example, consider some points.
Right, thank you. Just thinking about the system itself, somebody here has pointed out the fact that because it's train-borne,
yes,
you need power supplies, so therefore you're likely to need modifications to trains. Has that been an issue elsewhere?
Regarding the modification on the train, we do not do a major modification. It's very a minor modification. This minor modification doesn't cause a big problem for the tram and train operators because sometimes the customer tells us, for example, if you do a modification on the train or tram, we might lose our guarantee period. And the train manufacturer said that, for example, you did a modification and your warranty is not any longer valid. But the modifications which we are doing is not that much big. We use the power of the train. And also we do a very, I can say, a tiny hole in the roof of the train for putting the camera. So that's all. Because the other components like the sensors will be installed on the pantograph itself. So we do not do major modifications on the train. And it has not been so far a big issue for us. You know, more or less, I can say that the train operator side all the time is concerned about what you're installing on the train. That's a fact. They ask us a lot of questions. They make a lot of, for example, topics with us. They ask for very detailed designs when we want to install the system or something like that. But more or less, because it's not a major change, it's okay totally, I can say.
Right, interesting. And I mean, maybe in the UK, with Great British Railways on the horizon, and let's say a more single type guiding mind, then it becomes less of an issue. I guess we shall see in time.
Yes.
Thinking about the data that you collect, because obviously there's a lot of data, and Farzad spent quite a bit of time explaining how all the data was picked up, how it was used. So who actually owns the data that's collected? Is it owned by yourselves? Is it part of the contract and therefore owned by whoever you're working on behalf of, Network Rail, if it was in the UK?
That is a very, very good question, Ashwat. I can say so far in different projects which we have been involved, there are some debates over the owner of the data. But more or less, at the end of the day, the Panto is not the solo owner of this data. Why? Because we are collecting the data from the line. So definitely the infrastructure manager, which the system has been installed for them, is the owner of the data. So whatever we need to do on that data, sharing it, or for example, discussing it with any other, needs the permission of the infrastructure owner. More or less, it was like this. But sometimes there is a debate that the tram operators tells us that you are installing the sensors and the camera on all trains. So we need to be the owner of the data. I can say at the end of the day, if you install a sensor or a hardware on a train, and that train goes through the network and collects the data from the interaction, this data ownership would be something half-half between the tram operators and the infrastructure owners. And both of them need to know that what is the situation with the ownership of this data. But the Pantogles is not the final order of the data. For example, we are not permitted to share this data with anyone we want because, for example, we are collecting that. It's not that way. Definitely it's on the customer side. But Ashwat, another point which we need to consider is that the different structures is available in the rail industry. For example, in some cities, the tram operator and the infrastructure operator are one entity. So here you don't have any problem with the data ownership. But sometimes they are two separated companies. Here it might be a little more, I can say, clarity is required. But so far, the data ownership has not been such a huge challenge for us because we share everything with the customer and get permissions for the ownership from their side.
So it sounds very much like that there are various options here, and so depending on the way that this may be contracted,
yes,
would dictate who owned the data. Because I think the concern was raised through the fact that if the client couldn't get hold of the data at some point because actually they didn't own it, where would that leave them?
Yeah.
So yeah, so I think yeah, so you've answered that really in terms of, you know, it is an option depending on how it's contracted.
Yes, exactly. And sometimes the customer says that, for example, you are collecting the raw data. The raw data is totally okay. For example, if you want to do processing or whatever, but when you are detecting some kind of defects in the line, you are not permitted to share it with anyone. Even sometimes the infrastructure owners limit us to share the data with the tram operator of their city. So this is a case, another case regarding the defects specifically. Yeah.
Okay, thank you. On a slightly different subject, Colin asks, are there any speed restrictions or limitations on the product? And he gives an example of 360 kph, for example.
Mhm. Regarding the speeds which we can somehow install our system, I can say more or less we divide our product, the vibration product, in two main categories. One of them is light rail, which is the cities. The speed more or less is around 70 and 80 kilometers per hour, which we does the installation, and it has its own, I can say, data analysis approach, because the thresholds based on the speed is totally different. But we are capable of doing the installation on trains with higher speed. We have the experience of installation on the train with 150 kilometers per hour as well. But the process of the data analysis for the collected acceleration is totally different because of the speed. So if I can summarize my point, this system with some adjustments can be installed both on heavy line with higher speeds and lower speed on the light rail, and has two different pipeline of data analysis for detecting the defect.
So it sounds like it can be flexible in terms of
yes, it can be flexible. Yeah, but it's not limited to the type of the pantograph, to the type of the train. We don't have any dependency to these topics, because we exactly design our system installation specifically to the trams which we are going to install. We get all the drawings of the train, drawings of the pantograph, and then our engineering team design a fixture to install them in the best way and format. So I can say overall the dependency is very low.
Right, thank you. A couple of people have made comment on the application. We're obviously looking at an OLE application here for pantographs, but could it be used on conductor rail? And in fact, could it be used on other systems where we know there are risks? Can this philosophy or this functionality be used elsewhere?
By elsewhere, you mean some other things, for example, like trolley buses, something like this, you mean?
Well, certainly the third rail or the conductor rail system.
Third rail system.
Quoted
Okay.
here,
yeah. On the third rail, we have not so far worked anything, Stuart, because I believe that it's totally another, I can say, area. This is true that it is under the electrification umbrella, but it needs its own AI algorithms, it's maybe specific sensors. At PantoHealth, we are very open to further developments of different aspects of this electrification monitoring. But at this stage, we would like to make a success story, specifically on the overhead line. And after that, based on the demand of the market, maybe we extend it to the third rail or the other business cases.
Okay, thank you. Rami asks, do you monitor pantograph forces in the root causes?
Pantograph forces?
Yeah, I might have to ask. Rami, are you there? Can you unmute and ask your question in case I've done the wrong intonation?
Hi, Stuart. You hear me?
Yeah, we can. Yes. Go ahead.
Yeah. Farzad has talked about the root causes, about the thickness or decreasing the thickness of the wire. And he talked about the pantograph strips and the alignment issues. So I wonder if they already monitor, or they are doing the monitoring of the pantograph forces to the wire to analyze the root causes of the thickness decrease or the thickness of the wire itself.
Okay, Rami, if I'm not mistaken, definitely you're asking specifically about the uplift force which pantograph just causes to the catenary. I can say that we don't install any force sensors. We install the acceleration sensors, and more or less we are somehow focused on the catenary side. But in some cases, when it is important for the customer to consider the force measurements as well, we can add some kind of force sensors from our partners to our module, so we can exactly measure this force of the pantograph and the uplift force. So it is something feasible, but we don't deliver it, I can say, in our ready-to-market product. It needs some customization, which we need. We do that.
But it hasn't been included. It hasn't been included in the root causes of the analysis that you have shown, or Farzad have shown.
Yes, I think it is not included because we don't have the force, but I can ask it, I can say maybe in more detail for you if you want, because I'm not that much a technical person, but I know that in some cases, based on the request of the customer, we add the uplift force and the force sensors into our modules, and we don't generally measure that.
Thank you.
And if you have noticed, Farzad has always mentioned this chain, this ring in the chain, that sometimes you need some kind of inspection gates to monitor the behavior of the pantograph specifically, because we are not that much specified on the pantograph side.
Thank you.
You're welcome.
Okay, Rami, thanks for coming and asking the question. I've got one, possibly two more. I'm going to go for Khalid's question, which is all about the fact that the equipment's installed on top of the train. What sort of measures need to be taken to guard it from the environment in terms of adverse weather, rain, snow, lots of sun, whatever?
Okay, that's a very good question, because we install our sensors and the components in different weathers, different areas and regions. For example, we are going to have an upcoming installation in Delhi Metro with a very high pollution rate, which causes a lot of problems for the, for example, camera dust and things like that. Overall, because we are providing all of the components of our system from the rail industry certified companies, more or less they give us this guarantee that, for example, in what range of the weather they work and what is the best way, for example, to protect them by the hosing or the other components. So more or less we have addressed the problem of this adverse situation of the weather with these certified component providers. We have exactly the range. We ask these inquiries from the customer. If, for example, customer mentions that, for example, in this region, we experience 50 centigrade degrees in summer, maybe we need to reconsider about the supplier, which is supplying, for example, the mini PC or the camera or whatever to us. So somehow we are addressing the problem with this, and we exactly review it with our technical team when we receive a requirement from the customer in terms of the weather and climate situation.
Okay.
I hope,
Yeah, that sounds great. Thank you. One last question, and it comes from a slightly different angle. The question is, what kind of database is used on the project?
The databases which we are use is AWS. We collect the data in AWS in a cloud-based system. And then after that, we process our data in the MongoDB databases, and we just work on that data for the analysis. So it's a cloud-based solution.
Well, Saravana, I hope that answers your question on account of that's out of my remit then. I'm out of my depth at that stage. That's the end of the questions as I see them. Unless anybody wants to just put one last one on. Oh, hold on. Yeah, I'll go for one last one. Madden has asked, presentation shows the decrease in the thickness of the wire. Does Panto Health only detect the problem, or gives an idea how the root cause of the decrease of thickness of wire?
Definitely at this stage, more or less, we detect that where is the problem and what is the problem with the labeling. As our system gets more educated with the collected data from the line and feedbacks of the people which are working in the field to our system, that, for example, this spot that you showed us has this problem with these labels. Definitely in the future, we are going with this approach to make some kind of prescriptive maintenance as well. It means that we exactly tell the customer that what you need to do at this specific kind of problems. For example, you need to decrease the length of the dropper for 2 centimeters, something like that. But at this stage, we are more focused on where is the problem and what is the problem. But we need the customer's feedback in the loop to educate our AI.
No, that makes sense. So thank you very much for that.
You're welcome.
So Mahya, thank you for answering all the questions that were posed very comprehensively. That's great. Thank you.
Thank you.
Please give our thanks to Farzad as well.
Sure, thank you.
I will drop you both a note a bit later, thanking you on behalf of the PWI. So just before we finish, just to say that if there are any other questions which haven't been answered, haven't actually been asked, we do have a dedicated LinkedIn feed where you can go on at the PWI and you can ask them. And if you're happy to pick those up, the conversation can be continued, which then allows, say, perhaps other things. Not only that, but also the fact that people will be watching this on record, perhaps. So an opportunity for them to ask some questions that they couldn't do during the live debate. So finally, just to talk about the last couple of things I mentioned before, we've got the PWI Technical Conference, Electrification and Innovation, Rail's Path to Decarbonisation next week. That's the 2nd of July. That's in Cardiff. You can still get tickets and there is still some sponsorship and exhibition opportunities. And we have our last Lunch and Learn session of this semester. So 8th of July. We're on overhead line again, adventure advances in OLE survey. So those of you interested in overhead line things, I look forward to seeing you in 2 weeks. So from me at the PWI, thank you very much for joining. I hope you found it instructive and interesting, and we hope to see you on future Lunch and Learn sessions. So have a great afternoon, everybody.
You too. Thank you for inviting us. It was really nice meeting you all, and I will be in touch with anyone with any questions.
That's great. Thank you.
Thank you. Have a good day. Bye.